Hello, welcome to our today's session on tackling networking issues between users and cloud apps. We will be starting momentarily. Okay, good morning, good afternoon, good evening, everyone. Welcome to our webinar. Today's topic is tackling networking issues between users and cloud apps. I'm Arthur Kane, and I'll be your host for today. I'm very thrilled to welcome two special guests. One is Shishir Agarwal, who's Senior Product Manager for Google Cloud Networking. Hi, Shishir. How are you today?
I'm good. Thanks, everyone, for joining this webinar.
Excellent. And the second guest is Boris Barak, who's with Flowmon, and Boris is responsible for cloud technologies as the product manager. Hi, Boris. Welcome.
Hi, everyone.
Okay, without further ado, I'll jump into the content. So I would like to let you know that questions are open. Feel free to send any questions, feedback, or concerns that you may have. We will try to answer them either during the session or at the end. There'll be plenty of time. We are also recording the session, and we will share the link to the recording with you after the webinar, together with some related content. Now, the agenda for today is to talk about a few challenges that come with delivering applications from cloud. And those challenges are around how today networks are very heterogeneous and hybrid. How many people now work from home, and we're losing control over their connectivity. And we will also look at our options on actually seeing network traffic in the cloud. Then we will ask Shishir to present us with a Google Cloud packet mirroring technology that enables visibility into traffic within Google. And then we will continue with introducing how Flowmon can leverage this technology to provide performance and application monitoring in the cloud. This will be presented by Boris. And at the end, we will go through your questions. So what we see today is a shift of how we deliver and consume apps. Years ago, app was, or app server was a server that we accessed through a local network. It was very short distance. Let's say we had everything under control, both the infrastructure, the networking part, but also the server and application part. Then, for mostly economical but really scalability reasons, we have started leveraging data centers and moving our clubs there. Then, with the rise of public cloud, everything got so much more easier. And so we also shifted delivery and hosting of many apps to the cloud. And more often, our users are actually accessing SaaS applications that we don't own ourselves, but we only consume in form of service. But also our users have moved from local networks and office buildings to their home office. And in the times when there are no lockdowns, perhaps even coffee shops and other places. And this all creates obstacles in the visibility that we're used to from our local networks. In fact, the lack of visibility is actually being accounted by about 90% of organizations in this research by EMA. And all these organizations claim that the lack of visibility is their big concern and is slowing their digital transformation. But also the shift of users from local networks and office buildings to home offices is of big concern, especially to HR leaders, where over 50% of them claim that the problems with technology, with infrastructure, and overall inaccessibility, potential inaccessibility of critical applications is the biggest barrier for their workers to perform their duties. I mentioned SaaS applications. Even though they are completely out of our control, we don't monitor the network between the users from home to this application. We don't own or control the application itself. And while we are able sometimes to get information from SaaS providers on availability of their technologies, we're not usually able to effectively monitor their performance, response times, etc. It's not a big issue. We can leverage synthetic testing that Flowmon offers in our portfolio that will measure SLAs, application availability, and general performance for us. So while SaaS monitoring is limited, it is not impossible. But that does not apply to applications that we host ourselves in public cloud environments, where we can definitely get much more and much better visibility. And we should, because in order to ensure that our users have the best experience as possible, but also if the application is used by our internal employees, that they are actually productive and efficient in their daily routine, we need to monitor the performance and user experience more closely. However, there are some especially technical obstacles lying between us and this goal. First thing is that ideally, we would like to have technology that pinpoints the issue between network infrastructure, web application, and database, and not provide visibility into these points separately. Because this visibility is crucial in order to gain both experience monitoring, but also security and protect our assets. We are able to get some data. It's usually API log data, but they don't necessarily provide sufficient detail in order to do both SLA monitoring and troubleshooting at the same time. And this inability to see network traffic can be actually overcome. However, some means are very intrusive and not very privacy, I would say, privacy or I'm not really or intruding privacy. Oh, that one was hard. Okay, so how can we overcome that? Shishir, it is your time. I'll give you presenter rights. Can you tell us a little bit more about how within Google Cloud can we gain actual visibility into network traffic with your packet monitoring technology?
Yeah, thanks, Arthur. Hi, everyone. Okay, so I'll build upon what Arthur presented and talk about how you can get full visibility in Google Cloud with packet mirroring technology. So just to give you a quick overview of what packet mirroring is, this is a capability that's currently in GA. It's been generally available since March. What it does is it allows customers to actually get a complete copy of the network traffic. So for those of you who might be coming from on-prem, think about like virtual tab. You are able to get full copy of your network traffic, including payloads and headers. And that traffic, first of all, it's not sampled, which means that it provides you full visibility into your entire network traffic, which you actually did not have before availability of packet mirroring technology. Customers tend to use flow logs, which are great for providing what I call as bird's eye view. These logs are sampled, But for customers who are either for your network troubleshooting or security purposes, they really want unsampled full visibility, and that's where packet mirroring helps. Some of the main use cases we see with it are both for network operations as well as security operations. And again, both Boris and Arthur will talk to you a lot more about how packet mirroring can be used with Flowmon to help with your network operations and application and network troubleshooting issues. So just to give you some more details on how this technology works, in Google Cloud, what packet mirroring allows you to do is, first of all, specify the part of the network that you want to monitor. So as a user, you can say you want to monitor or you want to capture packets on your GC or GKE nodes. And then you can specify where do you want that mirrored traffic to be sent. In Google Cloud case, that gets sent to a collector endpoint, which is an internal load balancer, and behind which you have your collector instances. And these are the instances that will get this mirrored traffic. And you can do all sorts of analysis on this traffic for network operations or security purposes. And this is where, for example, Flowmon probe would be running and will be doing all the analytics. And just to give you, again, some more concepts around packet mirroring, essentially, as a user, you create a packet mirroring policy. You specify the front end, which is what is the part of the network that you want to mirror. Mirroring happens at the VM or instance level. And there are a bunch of options that I'll show you also in a demo quickly. And then you specify the backend, which is your load balancer endpoint. And the idea of putting it behind a load balancer is because then it allows your collector instances to seamlessly scale without having to worry about performance. Some of the other key highlights quickly that I want to call out, especially for those of you who might be familiar with other clouds such as AWS or Azure, with Google Cloud, this packet mirroring technology is available in all GCP regions and zones. And that is quite important for a lot of our customers because as a user, you are not worried about, oh, is this going to be available only in certain regions and zones. And we also support it natively for GKE clusters. So it's a very universal capability in that sense. A lot of our customers today tend to use GKE or containers, and you can use packet mirroring even with that. Compared to, for example, AWS, where it's only available in limited regions, and also it only supports certain machine types. With GCP, it's available on all machine types as well as GKE clusters. Also, in terms of performance, we have made it as part of our SDN fabric, which we call Andromeda, which means as a user, when you turn on packet mirroring, you pretty much have no performance penalty. It does take up bandwidth on the VM, and that is something that you need to be concerned about. But from a latency or CPU perspective, there is no performance impact of turning on packet mirroring. We also do not do any encapsulation on this packet mirroring traffics, which means that you get the packets, you get the raw packets, which makes it a lot easier for customers or partner solutions to analyze. So with that, let me do a quick, just high-level demo of how this works. Again, for those of you who are familiar with Google Cloud Platform Console, if you go to the UI within VPC Network, you will see a packet mirroring. So you can click that, which brings you to a landing page where, as a user, you want to create a policy. So you can click on Create Policy, and essentially you go through 5 steps. First of all, you define the policy name and a region. So it's a regional service. And you can also choose to just create a policy but not enable it, or maybe you enabled it, but then you can later disable it if you want. So some of our customers tend to use packet mirroring for on demand, like something bad happens, they enable packet mirroring for 30 minutes, an hour, and then they'll go back and turn off the policy. So once you do that, then you actually select the VPC network. So in this case, you can actually choose to have the source and the collector destination in the same VPC network, or you can choose to have it in a different network, which is peer to the original source network. So you choose the destination, and then you choose what are the instances you want to mirror. And here we provide a bunch of options. So you can actually specify the network based on a subnet. So maybe you have a subnet, which is your PCI subnet. You can actually do that. You can also have network tags. Maybe you have a set of VMs that you have tagged as production VMs, and you can specify that you only want to mirror production VMs, or you can also specify individual instances. So all of those options are available to control the traffic volume and cost. And then you specify where do you want that mirrored traffic to go, which in this case is an internal load balancer. So if you already have an internal load balancer, you can point to that. If not, right from here, you can create a new internal load balancer and attach the mirrored traffic to this load balancer. And the last part here is we provide some additional filters, again, to control the volume of traffic. So you can choose to mirror all the traffic, or you can choose to mirror a part of the traffic, as in you can say, oh, I only want to mirror my TCP traffic or ICMP or UDP traffic. You can also specify IP ranges. So you can specify a CIDR range. Like, for example, you want to only mirror /24. So those are the options, again, to help our customers manage traffic volume and cost. And once you are done, a policy gets created, and the traffic starts getting mirrored from your selected instances to the collector VM, which in this case, there would be a Flowmon receiver or collector that would be receiving all the packets, and it would be doing that analytics. So with that, I'll hand it back to Arthur to tell you more about the solution.
Thank you very much, Ishir. That was very practical information. And now I'll give presenter rights to Boris. And Boris, it would be wonderful if you could take us through how can we now tap into this data that we gained from network traffic, and how can we leverage it for network and application performance monitoring?
Of course. So let's look at how we can utilize what Shishir just showed you with Flowmon. First, I will start with a brief overview. Let's look at the concept of application performance monitoring, and then we will go through architecture and the visibility you can actually gain by combining Google Cloud packet mirroring and Flowmon. Application performance monitoring. What your users actually care about is a smooth experience, which usually means quick response and also an error-free experience, which means we are actually looking at a client communicating with the server hosting your application. Then the application will do its magic and respond back to the client. This involves some time the request spends in the network, then some time it's spent inside your application server, and then some time spent traveling back to the client. All these three elements actually impact the user experience, and this is something you should look at to evaluate the performance of your application and specifically the user experience of your users. Because you need the entire visibility. You need to do the visibility through the network and through the application server and back through the network. Since modern applications are usually tiered in some way, so you have your application server, and there is probably a database server or other application server that's supporting your application. In order to be able to diagnose issues, you actually need visibility into these underlying tiers. So when your application server is trying to fulfill a user request, it will probably contact the database server. The database server will again do something, process your query, and then respond back to the application server. What that means is end-to-end visibility is very important. It's very important for the user experience and for you as the owner of the application being able to track what's happening. So if we look at the entire picture, end-to-end, you have a user who is communicating with your application server. The application server is communicating with the database server. The database server is responding back to the application server, and that is responding back to the user. And if you have a strategically placed packet mirroring, you can actually see all this traffic and evaluate your performance and your compliance with the defined SLAs, and you can do that in real time or nearly in real time, which is the most important part if you want to prevent issues from escalating and actually maintain reasonable satisfaction of users. So let's see how we can connect this to what Shishir was just saying and demonstrating. So I presume you already know about Flowmon probes and Flowmon collectors, but just for the sake of completeness, let's recap quickly. So you have the probe, which is an appliance used to process traffic, the raw network data, which for the purposes of application performance monitoring is producing APM metrics, which are sent to the collector, which then processes them and gives you the required visibility through the application performance monitoring dashboards, widgets, and analysis. So it's as easy as Shishir demonstrated. You basically set up a packet mirroring policy and make our probe the backend of that policy behind the load balancer. At this point, your network packets are actually arriving at a Flowmon probe monitoring port, and the rest is configuration as any other. So there are no specifics, since in Google Cloud, all this is nicely integrated into their stack, in their network stack. There is no decapsulation. There is nothing you need to configure specific to Google Cloud. And of course, since Flowmon probes can also produce flows or IPFix records, you can utilize the rest of Flowmon's functionality, whether it's visibility and troubleshooting, whether it's NDR, whether it's full packet capture and analysis. These features are still available. Today, we are just focusing on application performance monitoring. So how can you deploy Flowmon in Google Cloud? Because these probes have to be deployed in Google Cloud. Well, you can go into the Google Cloud Marketplace and look for Flowmon, and then with a click of a single button, you can launch the appliance and start using it. So you can click launch, then use Google's deployment manager to deploy it, provide a few details, mostly regarding sizing. The appliance starts up, you provide the license, and you can work with your Flowmon instance as you would on-prem. Since we are talking about application performance monitoring, you need to perform some initial configuration. In most cases, this means configuring the probe, then configuring the collector to understand what is your application server and what kind of application you are actually running to be able to understand the traffic and those APM metrics I was mentioning. And after that, you can just jump in and start monitoring the performance of your application. So let's look at what we are actually providing and what you can see in Flowmon with regards to application performance monitoring. Well, we are providing a centralized dashboard, which is the single pane of glass you can use to monitor your application and its health just by a single glance. So you don't have to do any time-consuming investigations. You can just look at the dashboard. You can configure your own dashboards. You can customize the dashboards, or you can use ones we are offering as part of presets to just get started quickly and then optimize as you move along. So let's look at various widgets and types of information we are showing in the dashboard. One of the most important ones is something we are calling the APM index, which is basically a numerical representation of the health and status of your application. So you can imagine this number representing how well you are actually complying to your SLAs. And we are also visualizing that in color. So green means everything is all right. Then if you move into orange, perhaps it's time to start investigating to get ahead of any possible problem. And then if you go into red, something serious is happening, and you have to deal with it immediately. So you can quickly find out what's the overall status of the system, even if the system is rather complicated. And as you can see on the slide, if your application is composed of multiple backend applications or multiple servers, you can actually see this information aggregated on the dashboard. This information can also be used for alerts or notifications, so you don't have to look at the dashboard. Flowmon can notify you if something happens, or something happens that requires your attention. The next very important part of the dashboard is breakdown when you look at or breakdown in terms of service level agreements. So in most cases, I would presume you have some sort of an agreement with your users, and you are specifying how quickly your application needs to respond, or how reliable it needs to be. And this is the agreement you are actually monitoring for. So you will configure application performance monitoring to look at individual transactions, and then visualize all transactions that are actually compliant with the SLA, then all transactions that are transgressing the SLA. And in color, you can actually see also how bad the problem actually is. So again, green means it's okay, you are still inside the SLA. And then as we go towards a more significant breach of the SLA, then the color turns yellow, orange, or red in the end. And you can also see the response time and how quickly you are responding to a percentile of your users, or to the average user, which is also very useful when you need to diagnose issues quickly and decide what to do next. Then if we get into technical details, and you are actually starting to diagnose your application, or you need to figure out what's going on, it's very useful to have an overview of error codes, which this can mean HTTP status codes, or some internal database error codes used by MySQL or similar database. So you can actually see that visualized. So if a technical person looks at the dashboard, they can understand what's going on if they understand what the codes actually mean for that particular application. And this can be also a basis for further analysis of what's happening. And this is important, because once you are actually aware of the issue, then you need to figure out what's wrong, and ideally fix it as soon as possible. So here, Flowmon will provide you a way to do a drill down, where you can actually connect what's happening from the user towards the application server, then from the application server to the database and back. So here on the slide, in the left upper corner, you can actually see that this is a HTTP request, probably from a browser. You can see the details of that request. You can see headers and information about the connection itself. Then in the bottom part, you can actually see time correlated transactions that your front-end application executed on a database server that's actually powering the application. So these, as I said, are time correlated, and they can help you diagnose any issues, because if you are seeing that this type of request is failing, and then you see a specific database query fail, well, there is a large likelihood that those two are somehow linked, and it's worth investigating. As you can see at the bottom, you can actually see down to the level of specific SQL queries. So you can really go deep and debug what's happening just from what you can see in the network. You don't have to log into the server. you can just use the information provided by Flowmon. Okay, so that's all for the basic demonstration, and I'm handing it back to Artur.
Perfect. Thank you very much, Boris. Well, now we understand both how to tap into the cloud infrastructure and monitor traffic, but also we understand how we're able to pick interesting and relevant information from it that will help us with SLA monitoring, availability monitoring, but also performance troubleshooting. The most common use cases are really to understand which applications have the worst response, and really to divide those that are impacted the most from the rest, but also to understand which transactions within error code so that we can point our focus onto the root cause of our troubles. How severe is impact for remote workers or specifically workers at some site? What are the relations and what actually or which part of the application delivery impacts the performance the most, whether this is application or network or a database, but also to measure how users are happy, productive, efficient in their work, and measure applications availability in the long run. Boris also mentioned that application performance monitoring isn't the only use case available with traffic visibility. Some of you are aware of Flowmon Packet Investigator, which is a technology for intelligent analysis of packet data. It's automatically looking for error codes, wrong configuration, or other root causes for connectivity issues. And it actually not only shows the root cause and explains it in human language, but it provides suggestions on remedial actions, and hence it automates the whole troubleshooting efforts and helps you with the response. So some of the benefits of monitoring cloud apps or monitoring cloud apps in general from user experience perspective is to improve productivity of your users, is to avoid customer churn, because we know that users are very quick in leaving applications if it doesn't load up, if it doesn't give them what they need. It is to minimize a business impact caused by this customer churn. And Flowmon provides you the best time to value on the market, with some 30 minutes between deployment and being able to see data on the dashboard. And with all of that, we enable you to take back control over decentralized IT that we explained at the beginning of our webinar, where users are working from home over networks that we don't have any control over, and access applications that we again don't have any control over. So to help you to find more information on these topics, we are more than happy, and we'll actually provide you links to these documents. One is specifically talking about the cloud application performance, and you can read more on the same topic that you saw before, that you saw today. But we will also share a link with you to network monitoring ebooks, which is a set of ebooks that explain network monitoring from wider perspective, and it shows different technology approaches and compares them. And on that, we have time for questions, and I read through some of them that we received, and thank you very much. And one repeated topic was pricing of the Google Packet Mirroring. This question is for you, Shishir. Can you answer?
Yeah, sure. So packet mirroring pricing has two components today. If you remember the picture I showed you, essentially the first part of pricing is based on the amount of traffic that you are mirroring, which is essentially the traffic that goes through the load balancer. So for example, if you mirror a gig of traffic, it's roughly $0.008, and obviously it's converted to the right currency for the right regions. So but deliberately we have priced it what I call it really low, because we understand that with packet mirroring, the volume of traffic could be huge depending on customers' environment, and we have lots and lots of customers today that are pushing terabytes of data, and even their monthly bill is very reasonable because of the way we have priced it. So there is no charge based on endpoints. A lot of customers are concerned about, oh, if I'm mirroring 100 VMs, there is some sort of charge per VM. That's not the case. You only pay for the amount of traffic that you mirror on a per gig basis.
Excellent, thank you. And what about some trial options? Can customers test the solution before they buy?
Yeah, I mean, first of all, again, Google Cloud in general offers a $300 credit for any services you want to try in GCP. So that's definitely an option. You can use that credit for trying out packet mirroring. But even otherwise, as I said, right, if you want to try packet mirroring on a certain set of VMs, the per GB charge is really low. So it should not cost you more than like few dollars to just give it a try.
Thank you. Another question is for Boris. Can we use this to monitor Office 365 or Google Office Suite applications?
No, that's not possible. That's actually something you, Arthur, were explaining in the beginning. These applications belong into the service as a service category, or SaaS category, which means they are not hosted in the part of Google Cloud you actually control. Therefore, you cannot set up packet mirroring, and you cannot see the traffic. There is one very special case where you would be able to see the traffic, and that if your virtual machine would be communicating with these services, then you can actually see the traffic, because the traffic is leaving the part of the Google Cloud data center you actually control. So in that case, you would, but not for any users or people working from home or anything like that. That's out of scope.
Brilliant, thank you. And one last question again for you, Boris. What about some other ways of seeing the traffic in the cloud in general? Shishir mentioned flow logs. Could that be one of the options?
Flow logs are one of the options, but again, I will reiterate what Shishir said. These are tools for providing the bird's eye sort of look at the infrastructure. So they have a completely different level of visibility. They are quite low grained. And for Flowmon specifically, we currently do not support Google Cloud flow logs, or we are not supporting them yet. So you cannot utilize this option. So you should go for packet mirroring for full visibility.
Perfect, thank you. And on that, let's close today's session. Thank you very much, all of you, for attending and spending this time with us. Expect the follow-up to arrive soon. Thank you to our panelists, Shishir. Hi, Shishir. Thank you so much for finding the time to present Google Packet mirroring.
Yeah, no, thank you for inviting me, and thanks again, everyone, for joining this session.
And thank you, Boris. It was a pleasure having you on the webinar today.
Thank you, Shishir, and thank you, Arthur, for hosting.
All right, cheers. Thank you. Bye.
Bye-bye.